Here we go, class. We're taking a quick look at medians and altitudes today. Kind of a couple ways of looking at this. The altitudes are always going to be the intersection point is really going to help us find the center of mass, which helps us when we're trying to balance anything, whether we're the cat in the hat trying to balance milk and umbrellas and rakes and fish and cakes and books and whatever else, whether we're just trying to balance an alarm clock, whether we're trying to balance a basketball. Additionally, when you set up these wind-powered generators, definitely need to have some balance and some center of mass considered into the whole equation so that you can figure out exactly what's going on to make it the most efficient you can. We'll hopefully go through an exercise in class where we actually have some random triangle that we'll have you cut out and work with, and hopefully you'll be able to balance this on the tip of your pencil. That's kind of the goal for tomorrow. As we work on this. But really we're going to be looking at the medians of triangles. The median is basically a segment from the vertex to the midpoint of the opposite side. So that's all that we're going to deal with when we're dealing with a median, and where the point of concurrency is going to be called the centroid, which is the center of mass, and we'll look a lot at this. Okay, so let's just jump into this. By the way, I wanted to try to make sure that you knew that this was kind of an important concept, this stuff here at the bottom. The median, basically from the vertex to the centroid, is going to be 2/3 the distance, and from the centroid to the other side is going to be 1/3 the distance. So when we look at this part right here is 2/3, this part's 1/3. This part from the vertex to the center is going to be 2/3, this is going to be 1/3. This is 2/3, this is 1/3. So let's take a look at this. The medians of a triangle intersect at a point that is 2/3 the distance from the vertex to the midpoint of the opposite side. Very wordy. Here's kind of what it looks like, and just remember this stuff down here that's starred. It'll be very, very important for us. So let's jump into this. G is the centroid of triangle ABC, where AD is 8, AG is 10, and CD is 18. Luckily, we have a triangle already written down here. This part's 8, this part's 10, and this whole part from D all the way over here to C is going to be our 18. So we're going to try to figure out some of these lengths. BD, from B to D, since this is a median, medians are made up of midpoints of sides. So if this is 8, BD also has to be 8. So I guess, I don't know, this isn't really great terminology, but the length of BD is 8. Okay, so that's where we're at. AB is going to be from here up to here. That's going to be 8 plus 8 is going to equal 16. Is going to equal the length of AB. That's not really good terminology again. EG is going to be this length right here. This is going to be 1/3 of this entire distance. This is representing 2/3. So if this is 2/3 and this is 1/3, if you are really good with your fractions, basically this is going to be half of this length. So this is going to be 5, this is going to be 10, the entire thing is going to be 15. If the entire thing is 15, 10 is 2/3, and 5 is 1/3. So the entire thing is 15. This represents 1/3 of it. This represents 2/3 of it. In other words, this guy right here is half of this guy right here. Okay? So EG is just going to be 5. AE, same concept here. AE is going to be the entire thing. That'll be 15. Let's look at the other median here. CG is going to be this part here. It's going to be 2/3 of our 18. 2/3 of 18, it's 12. Pretty sweet. DG is going to be the 1/3 of the 18, so that's going to be the 6. So basically 6 is this part right here, and 12 is going to be this part here. The whole thing adds up to 18. Not a whole lot of arithmetic. A lot of this stuff is done in your head. You're working with thirds and halves. Let's take a look at this one. This is going to be awesome. Find the coordinates of M, which is the midpoint of JK. So if I'm trying to find the midpoint of JK, I basically add together the x's. That would give me 4. 4 divided by 2 would give me 2. So I know that I'm going to be over 2. Let's see, 7 plus 1 is 8. 8 divided by 2 should give me 4. So I'm at the point 2, 4. This scale is by 2s, so I know that point is going to be right here. I'm going to call this M. That's awesome. Okay, use the median LM to find the coordinates of P, the centroid. So I'm looking at the coordinates of LM, so I'm looking at, ooh boy, this line right here. Now, the centroid happens, remember there was that starred piece, the centroid happens 2/3 of the way from the vertex to the opposite side. So 2/3. Let's see. This distance is from 4 down to -5, so the entire distance here is going to be 9. Okay, so LM equals 9. 2/3 of that distance, 2/3 of 9 is going to be 6. So basically from here I go up 6 units. So -5 plus 6 would be a +1. So I'm thinking that my unit right here, this P, is going to be over 2. It's going to have the same x coordinate, 2, 2. So one's going to be 2. And I'm going to go up 6 units from here, so that would be 1. Let's test this out. This is going to be up 6 units. This will be up 3 units. If I go up 6, that's 1. If I go up 3, that's 4. I got it. I found it. That's amazing. Okay, so that's the coordinates of, let's see, this is called P. P is my centroid. Part B says find the coordinates of N. N is the midpoint of JL. So again, I'll take -2 plus 2. That gives me 0. When I divide 0 by 2, let's see, I'm going to be at 0, so probably right about here. Secondly, I take 7, and I'm going to add -5 to it. That gives me 2. I divide 2 by 2, I get 1, so I'm going to be up 1. This is going to be my coordinates for N. It'll be 0, 1. Awesome. Oh, yeah, 0, 1. From there, what I'm going to do is I'm going to verify that KP is 2/3 of KN. So KN is going to be this entire line right here. There's KN. I need to figure out that KP. Where in the world is K? I have no idea where K. Oh, here's K. Here's KP is going to be 2/3 of KN. So let's figure out what these lengths from 0 to 2. This is going to be a length of 2. From 2 over to 6, this is going to be 4. So I'm trying to verify that the entire length 6 is 6 2/3 of 4. I think it is. I don't know if I said that correctly, but 4 is going to be 2/3 of the entire part of 6. So that does work out. Verified. There it is. Check it out. That was kind of cool. I like that. Next, it says given that AB equals BC. So basically, AB, this entire length here, is going to equal BC. We're dealing with an isosceles triangle. Check it out, isosceles triangle here in the house. You're going to find AD. AD, well, that's got to be this part right here. There's AD. AD, well, we're basically going to have to figure out that that's going to be a midpoint. D has to be a midpoint here in order for this to work. In order for that to be perpendicular, this is at an altitude, that's going to have to be a midpoint. So AD is going to equal 12. The measure of angle ABC, well, if this is an altitude, if it's a median, it's also going to become an angle bisector. So this is 39, this is 39, 39 plus 39. Oh my goodness, that's 78 degrees. We got it. Number 14, given that G is the centroid of triangle ABC, find FG and BD. Okay, well, FG is going to be a little bit harder. It's this piece here. This is going to be the 1/3 of this length here, of the entire length, or half of this guy right here. So half of this is going to just be 6.5. So this guy right here is just 6.5. So if this is 6.5, it means the total length, 13 plus 6.5, is going to give us 19.5. And I bet you just about anything that if we had a calculator and we took 6.5 divided by 19.5, that we would get 1/3, realizing that this is always 1/3 the distance of the entire piece here. Next, let's find BD. Let's see, this is the part that's 2/3, this is going to be the 1/3. So basically if this is 10, this has to be half of it, this is 5. So 5 represents 1/3 of it, 10 represents 2/3 of it, together it's 15. So BD equals 15. Man, we're moving. This is awesome. Here we go. Copy and complete the statement for the triangle HJK with medians this thing, and this thing, and centroid P. Hey, I could probably use a triangle here. So let me draw a triangle. You could trace one, you could make one yourself. I'm just going to plot one of these guys. Look at this guy. Look at that. Triangle. Easy. Let's switch colors. We're going to label this guy H up here. This is going to be J over here. This is going to be K over here. If they don't give you a picture, draw a picture. Not a big deal. Just draw it. Piece of cake. Okay, quickly I'm going to go through here. I'm going to draw some sort of line. I'll draw with this blue piece. So we're going to talk about HN. This part right here is going to be HN, I guess. Okay, that'll be HN. Let me label that with an N. Here's my N. Let's see, this is going to be J over here to L. And I'm going to have, let's see, K up to M. I'm just using these pieces right here. Let me go through and draw these really fast. We'll take this guy, we'll say K over here to M, something like that. We'll take J over here to L, something like that. There we go. So we got a triangle. We drew this really quickly. You could probably sketch it faster than I did trying to use all these tools. Big deal. You're just showing off. Okay, let's take a look at this. PN. So, oh, this is P right here. PN. So we're looking at this part right here. PN, this is going to be the 1/3. How is it related to HN? Well, this is going to be 1/3 of HN. So the relationship is it's 1/3 of the entire thing, which is HN. PL now. PL is this little part here. It related to JP is actually going to be 1/2 of JP. So this is 1/3 of the whole thing. This is 2/3 of the whole thing. 1/3 divided by 2/3 gives us this 1/2. Pretty sweet deal. KP. KP is right here. KP compared to KM is going to be 2/3 to the 1/3. KP is 2/3 the whole thing. So it's going to be 2/3 right here. So we have a 1/3, we have a 1/2, and we have a 2/3. We're playing with fractions. Sweet. The problems keep coming. Here we go. Point G is the centroid of triangle ABC. So there it is, centroid city. Use the given information to find the value of x. This is going to be awesome. You're going to love this. Okay. So now we have to set up some sort of equations, so algebraic equations with these. So I'm just going to set these two equal to each other. Let's see, this is going to equal 6x. Okay. So CE is the entire thing here, the entire median. CG is just going to be this part that's going to represent 2/3. So what I'm going to have to do is I'm going to take 2/3 of the whole thing. 2/3 of the whole thing is equal to the smaller piece. So since this one's smaller, we leave it alone, and the bigger piece we have to take 2/3 of. Okay, so this CE is the whole thing. We're taking 2/3 of the whole thing to represent the smaller piece here. Hopefully that makes sense. So let's see, 2/3 would be 2 times 6 is 12, divided by 3 is 4, so this is 4x equals 3x plus 7. We'll subtract 3x from both sides. We have x equals 7. That's our first answer, x equals 7. Use the given information to find the value of x. I don't even need to substitute it in. So there, sweet. Number 19, FG, that's from here up to here, is x plus 8. AF, the whole thing, is 9x minus 6. So 9x minus 6 is the whole thing. Then we talk about x plus 8. X plus 8 is the 1/3 versus the whole thing. So we're actually going to take 1/3 of this first piece, of the big piece equals the small piece. Two ways you could do this. You could either multiply both sides by 3, or you could just, since both the 6 and the 9 are both divisible by 3, we could just do that. We'll distribute the 1/3. 1/3 of 9 is 3x. 1/3 of 6 is 2. And this will just equal x plus 8. We'll subtract x from both sides. That gives us 2x here. We'll add 2 to both sides. That gives us 10. That tells us that x equals 5. Wham! Let's circle that. Third one, we're at 20. We're going to say 5x is going to have some relationship to 4x minus 5. Let's figure this out. BG goes from up here all the way to down here. BG, that's the 2/3 part. DG is the 1/3 part. Oh, this is going to be crazy. Okay, so the relationship here is this is going to be the big piece, this is going to be the small piece. Technically, this is twice as long as this piece. So here's what we're going to do. Let's see, this part we're going to multiply by 2, because the small piece times 2 should give us the big piece. The small piece times 2, this piece right here times 2 should give us the same length as this piece here. A lot of people will try to 1/3 and 2/3 and everything else these, and they'll kind of mix them up. So really be careful when you're working with your 2/3. Sometimes it helps to say whatever it is that you're doing out loud. This will give us 3x here. We'll add this over here. That'll give us 9. X equals 3. We're done with this page. Peace out. Oh man. Find the coordinates of the centroid. This is a hard problem. These are hard problems, especially this one right here. Okay? Let me walk you through 8. I think we're just going to do one of these just because of time. I don't want to waste your guys' time. But here's what I would do. I would go through and I'd plot each of the points. If you have a graph, use a graph. Okay? Look something like this. Secondly, I'd find a nice midpoint. So I wouldn't necessarily find the midpoints between these guys because it's not going to be that nice. It's going to be kind of like right here-ish, which will be okay, but not great. You could find the midpoint over here, but again, it's probably not going to be great. This one, since you have the same y coordinates, this is going to be awesome. So just find that midpoint. Bam. Got it. The midpoint is right here. I probably should have stepped back one more step here. But here's your midpoint. From there, you know that this is going to be your median from here to your midpoint all the way up to this place. Notice that they have really nice, the same x coordinates here. So that means they line up perfectly. I can figure out this entire length here is going to be 9. The entire length is 9. So this is going to be 2/3 of it since I'm going from, oh, I think I messed that up. I think I got to go the other way. I think this needs to move up to like this. So from the vertex down, that's going to be 6. From the vertex down, this part's going to be 6. This part down here is going to be 3. So if I wanted to find where the centroid is going to be, I would say that P is going to be -3. And then let's see, 5 minus 6 would give me -1 for my y coordinate. That is my centroid. Okay, so from the vertex down, that's going to be your 2/3, and from the centroid to the side is going to be the 1/3. So that's where I got this. I found the whole length by saying 5 to -4. That's 9. 2/3, 1/3. Let's move on. You guys can do 9 on your own if you really feel like it. Altitudes. That's the second thing. Okay, altitudes. You see altitudes a lot whenever you're trying to find the height of stuff. So down here, the measures of triangle. In the area formula of a triangle, you know it's going to be 1/2 the base times the height. Well, you can use the length of any side for the base, B, but the height's special. The height is the length of the altitude to that side from the opposite vertex. So what are we talking about? Say we're going to use PR as the base. That's our base. This guy over here has to be our height. Height is always a perpendicular distance from this opposite vertex straight down. That's our height. If you have an obtuse triangle, though, check this out. This is your base over here. PR is your base. Your altitude is going to be from this vertex straight down, which, look at that. It's on the outside of the triangle. How ridiculous is that? So this is going to be your height over here. Kind of weird when you're finding the area of obtuse triangles. Watch it, but altitude's pretty important. So let's check this out. The concurrency of altitudes of a triangle. I'd never say this out loud, but this is called the orthocenter, which is kind of like a stupid center because there's not really a huge point to it. Scientifically, there's a couple things, but I'm not even going to mention them because they're not worth mentioning. But basically, you're going to connect all your altitudes. There's not a 1/3, 2/3, anything going on here. They're just kind of altitudes. And they meet somewhere in here. We're going to call that the orthocenter. What's neat about an orthocenter is sometimes it's on the inside. If you have an acute triangle, it's on the inside. If it's a right triangle, whoa. If it's a right triangle, it's on the triangle. It's on one of the sides. It's right there. Thirdly, no, it says it's right here. It's right here. Check it out. It's right there. P's right there. And then if it's obtuse, where's P at? P's all the way out here. How ridiculous is that? P's on the outside of the triangle when you're dealing with orthocenters. That's what you did if you worked on your project. Your obtuse was actually outside of your obtuse triangle. Your orthocenter was outside. Orthocenter, obtuse, outside. They all start with O. Pretty good way to remember this. Orthocenter, obtuse, outside. I don't know how else you're going to remember it. Don't mix it up with on because that's going to be a mess. Okay, isosceles triangles. Whoa, this is a crazy idea right here. Isosceles triangles. In an isosceles triangle, the perpendicular bisector, the angle bisector, the median, and the altitude from the vertex angle to the base are all the same segment. What are you talking about? Well, I luckily have an isosceles triangle right here. And if you look at this line, BD, let's talk about what it is. Well, first off, this is a perpendicular bisector, right? What does it bisect? Well, it bisects this side over here. It's definitely perpendicular. It goes through B. We're set. It's a perpendicular bisector. Secondly, is it an angle bisector? Well, yeah, we could probably come over here, and by CP/CTC, we could probably easily prove that those two angles are congruent. Thirdly, is it a median? Well, yeah, it divides this side in half. These are bisected, and then it connects to the opposite vertex. Sweet. And is it an altitude? Well, sure. It goes from B straight down, makes a right angle. It's also an altitude. So it's all four of these. Okay? In an equilateral triangle, this is true for the special segment from any vertex. So if you have a equilateral triangle and you were going to try to find the center, it doesn't matter what method you use, because your altitude is going to be the same thing as your median, is going to be the same thing as your perpendicular bisector or your angle bisector, and that makes this center would actually be your orthocenter, your centroid, your incenter, and your circumcenter. Can you believe it? That's out of control. Okay, let's look at number 10, 11, 12. I would look this thing over. This is a really interesting concept, and if you have questions on it, make sure to ask, maybe draw this out. This is pretty amazing how this works with an equilateral triangle and also isosceles triangles. These are really special cases. Okay. Is BD a perpendicular bisector? It definitely is here. Then is it a median? Is it an altitude? Okay. In this case, it's all three of those. In fact, it's even an angle bisector, but that's not even one of our choices because it's really hard to show that's an angle bisector. So by these three, that's all it's really asking for. It's all three of those. This guy, this BD, well, look at it. Does it bisect anything? It doesn't show it on here. So the only thing that we can really say is that this guy's an altitude. Altitude. This guy over here, it definitely divides this side, so it's some sort of bisector, and it connects to the opposite piece. So I would definitely say that this guy is called a median. Remember, medians are midpoints connected to the opposite vertex. That's what we use to find the centroid. Okay, maybe the toughest questions yet known by mankind. Here it is. The median of a triangle is always, sometimes, or never the perpendicular bisector. Whenever you're dealing with always, sometimes, never questions, you got to think about isosceles triangles. You got to think about right triangles, maybe a scalene. You got to think of obtuse triangles, acute triangles. You probably think about equilateral triangles somewhere. Think about every single type of triangle, whether it's green, blue, purple, or pink with polka dots. Who knows? You got to think about every single type of triangle. So the median of a triangle is the perpendicular bisector. Well, that happens sometimes, right? It does happen if we're dealing with an isosceles triangle or an equilateral triangle, but it's not always the same thing. So I'm going to call this one sometimes. The altitude of a triangle is a perpendicular bisector, always, sometimes, or never. I think it's the same question here, and we just looked at it back with this idea right here. When you have an isosceles or an equilateral triangle, these guys are sometimes going to be the exact same line, the exact same segment. So that's kind of what's going on here, sometimes and sometimes. The medians of a triangle, always, sometimes, or never, intersect inside the triangle. Okay? The medians of a triangle. So this is going to be concentrated on just the centroid. Okay, and we didn't really formalize this, but for the centroid, because it's the center of mass, the center of mass is always inside the triangle. Doesn't matter how you work it, the medians are always going to cross on the inside of your triangle. So it doesn't always intersect inside. Centroid is always, always, always inside. Lastly, number 24. The altitudes of a triangle, always, sometimes, never, intersect inside the triangle. The altitudes, again, this is going to be your ortho center. This is the stupid center that doesn't really have a point to it. The altitudes can sometimes be on the inside, sometimes on the outside, and sometimes on. Okay? It's inside when you have an acute triangle, it's on it when you have a right triangle, and it's outside it when it's on an obtuse triangle. Okay, these are what you're going to have to remember. This is going to be on a quiz and a test, so this is going to be a sometimes. Alright guys, it's your turn to show off your amazing mathematical ability. You have some picture down here. Oh, this looks kind of like a coordinate proof. Holy smokes, coordinate proof. Well, what do you have to prove and how do you have to do it? Well, let's look at this. In exercises 9 through 14, you will use the triangle shown in the coordinate plane to prove that the medians of triangle ABC are concurrent. Now, this is going to be a coordinate proof. So basically the idea is that if it's asking you to do something, tell me what formula you're using and then actually use just these letters provided like BC or A0 or 00 in order to find whatever you're finding. So number 9, it says find the midpoints of each side of the triangle. So you'll find the midpoint, the midpoint, and the midpoint. Remember, to find a midpoint, you just add together your x's, divide by 2. Add together your y's, divide by 2. That becomes your midpoint. Add together the x's, divide by 2. Add together your y's, divide by 2. That's your midpoint. Same thing here. Number 10, find the equations of the lines of the median. Holy cow. So you're going to find the equations of the lines of the median. So you're going to use this midpoint and this point right here, and you're probably going to say, okay, to find the equation of the line, I'm going to have to find the slope. And then I'm probably going to put this into something like slope-intercept form, something like this. Good luck finding that. Maybe it would be better to use point slope. Y minus y1 equals mx minus x1. Figure out how you want to do that. This might be the best way to do that. Put that into slope, point slope form, and then maybe just solve for y quickly. Might be the best way to do this. Find the point of intersection between M1 and M2. So these lines, and what you're going to do is basically if you've solved for y, you're just going to set one equation equal to the other. So for instance, if you had like y equals 2x plus 4, and you had y equals negative 3x minus 1, if they're both solved for y, what you do is you just say 2x plus 4 equals negative 3x minus 1, and you actually go through and you solve for x, and then put x back into either one of these equations and solve for y. You'll get some point as your intersection. Remember, the crazy part is these points are probably going to be a's and b's, and there might be some fractions involved. Next, you'll do the same thing for b, and then for 2 and 3, and then 1 and 3. Ideally, all three of these are going to be the same. It'll probably be some sort of fraction with some letters. And then it'll say, are the medians of these concurrent? Explain your reasoning. Basically, if all three of these are the same, the same intersection place, then that is your centroid. They are concurrent because they intersect at the same point. Call the centroid. That would be kind of your reasoning. So check that one out. Try it. It'll be due tomorrow. I think a good idea would be to write it in some nice form. Let me show you. Maybe to write number 9, the midpoint of AB, and have basically whatever your midpoint is. The midpoint of BC is this. The midpoint of CA is this. Equation is this. Equation is that. Equation is that. Keep going. Just make it really, really neat that we can look through it. We can grade it out of 10 points tomorrow. All right, guys. Remember, when you're working with math, if you're not part of the solution, you're part of the problem. Math is life. I'm out.